Hello everyone, welcome to my project videos. I am Zulkarnain Prastio. Okay. In these videos, I will try to guide you to know about how to use machine learning from scratch and how this learning component works. My project title is Recognize with Your Machine Learning, building machine learning scratch using the learning component function called Logistic Regression in Python. Okay, I am Zulkarnain Prastio. I am a student of Pacman AI Batch 9. I have been working on the project. So, this course, Advanced Machine Learning, I will try to use story about my videos to use Scratch Logistic Regression machine learning algorithm. So, in these videos, I have again the project. The first start, I will explanation of learning component of algorithm, logistic regression. And part 2, I will try to story about this project again. The project is PC the code explanation of logistic regression algorithm. And third project, I will do running through the coding process. And then I will implementation and experimentation of code for modeling. And finally, I will do summary or conclusion from implement a logistic regression. And I have key insight gained from the analytic analysis and experimentation. And I hope this conclusion or the effectiveness and applicability of the code from scratch. Okay. The first time, I will to try explanation of learning component of algorithm, logistic regression. You know, logistic regression is not a regression. It is a binary classification model, class 0 and class 1. So, logistic regression is not really a regression. It is classification, specifically binary classification. It is used to predict binary outcomes from a linear combination of variables. So, there are two possible outcomes that represent two different classes, class 0 and class 1. For example, we can use logistic regression to classify whether an email is spam or not. Based on the subject and content of the email, now you know what logistic regression can do. In this example, so you can look the email not spam and spam from subject and body. So the next question might be how to do it. How does the model classify data? The simplified foot, there are only two steps. The first step is to get the probability of classifying a data point is class 1. This uses a function to project a linear combination of all futures into a score between 0 and 1 that represent to the probability of being in class 1. This function is called a logistic function or sigma function. This is formula from sigmoid. It does look like a big S and will map any value into a range from 0 to 1, a positive number being a high probability and a negative number being a low probability. And the second step is to predict to class based on probability. How does the model classify data? Predict classes based on probability and threshold. In here, I use the promise step and the threshold I set. If the probability is greater than the threshold, then the prediction is class 1. And otherwise, it is class 0. For example, if I set the crash course as 0.5, then if the probability is greater than 0.5, then the prediction is class 1. So the next agenda project is pseudocode explanation of logistic regression algorithm is highlights implementation main function. This is code bolding. Okay, I just gave an overview of logistic regression. Let's see how to implement it. For the implementation, I follow the main plus and helper function approach. The main function contains the main logic of the algorithm and leaves the details to be handled by the helper function. Okay, you can look my code. Use logistic regression. Now, let's start with the main function. First, I initialize the parameters. I distinguish beta 0 and other betas because beta 0 has a different shape or gradient than others betas. So you can look gradient beta 0, gradient beta others. This code, I use the helper function to get the gradient of each beta. Next, beta 0, beta other equal update params. And finally, I use another helper function to update the beta value using the gradient. And I will come back for in range iteration. I will come back to step 2, some iteration. Okay. The next code. Now, let's discuss the help function. The first help function is for initializing parameters. In this code, I only set the initial value of beta 0 at 0 and the another initial values of beta as random values. You can look this. Okay. The next function is to calculate the gradient. I have seen the gradient equation on each parameter. So the first time, I have gradient beta 0 equal 0. And then I have gradient beta other equal 0. and then I will for each point in enumerate. The next time I will predict logistic function point beta 0, and then I have gradient beta 0 plus equal predict mean y I per m, and I will come back to predict mean yi future per m. So first time I initials the gradient beta 0 at 0 and beta other as a factor of 0. Then I iterate over all the data points to accumulate the gradients calculated for each data point. And the next, inside the for loop, I first get a prediction using the Logistic function. Then the other gradient and beta are represented as the prediction minus yi times the g future of data point I. Then I get a gradient at beta 0, which is the prediction minus yi. So I will accumulate the gradients of all the data points and normalize them by the number of data points m. So the next continue code. In here is the code for fitting the logistic regression model. Okay, number one, I have the compute gradients xy, beta 0, beta other, mn. And then I have gradient beta 0 equal 0. And I have gradient beta other. So from the code logistic regression for fitting, output this code is I have gradient beta 0 is 0.1666, and I output gradient beta others is 0.6666, 0.83333 until 1.0, and output from this code is 0.6931. Okay, the next discontinue from code, I will to try update forums. You can look minus equal. So this function from code to dev update forums to helper function, I will to update the beta value based on the gradient. One thing I want you to notice is the sign when I apply change to beta. So it depends on how I calculate the loss. In the function, I subtract the observation from the prediction. From 0, dy equal predict mean y, I have upper estimate. And then output, I have positive value. So If the prediction is too high, the gradient will be positive, and I have to subtract the gradient from beta. And how to beta nu? To output equal beta all minus positive gradients. Well, I need to subtract the gradient from beta. And next, about the error dy equal yi minus predict. So if I want to beta nu, I will try to beta all positive gradient. So if I do it the other way, that is subtracting pi from yi, I have to add the gradient to beta. Okay, the next from code logistic regression, I have the logistic regression xy iteration 100 learning rate equal 0.01. Will I have beta 0, beta order equal initial params and update params. Finally, let's look at the complexity of implementation. This time, I will do complexity to implementation. Both parameter initialization and other parameter function look to all betas once. But are active. And then I have gradient beta 0, gradient beta order to compute gradient xy beta 0, beta order mn 50. Now, in this function, I will calculate the gradient going to each data point and each filter. So the time complexity is OMN. I will come back for in range iteration. It means if the number of iteration is I, then the overall time complexity is O, M, and I in terms of space complexity. The next, I will again gradient beta 0, gradient beta order equal compute gradients xy beta 0, beta order mn 50. So the only intermediate variable I created was to store the gradient. So everything is down. Okay, to implementation mini batch gradient descent. I have to building to create the compute gradient mini batch to this project. After understanding the concept, to implementation is quite easy. In fact, there are only a few changes we need to use mini batch gradient descent. In this function, I will to calculate the gradient. I did another input parameter, bit size. Then each time I randomly sample a number of data points with size equal to bit size. Then the gradient is calculated as the average of the gradients contributed by those data points. This is the code referred to in the statement just described. Okay, I will try to guide you, but this is the code fitting the logistic regression model. The first time this code, I create import numpy as NV, and then the logistic regression xy learning rate equal 0.01, num iteration 1000. Okay. In this update code, the logistic regression function is defined to summarize the logistic regression algorithm. It takes input data X, target variable Y, learning rate, and number of iterations as arguments. Within the function, the gradient descent algorithm is performed, and the train, weight, and bias are returned. Finally, the function is called with the input data X and target variable Y, and the train, weight, and bias are print. You can look this print the train, weight, and bias. So, because the variable X and Y are not defined, I need to replace X and Y with the actual input data and target variables. The code above is the improved code. It is improved code. I did a use case with placeholder values for X and Y. From replace X and Y with your actual input data and the target variable. From fitting the logistic regression model code, I have output. Yes, the output train weight is 0.1591, and then minus 0.01006, and then minus 0.1793. And output from train bias is minus 0.169 to 4411. Okay, we'll try to running through the coding process in this agenda project. I will visit the code making prediction training logistic regression model. So in here, this is the code for making prediction with the train ones. So logistic regression model is import numpy as NV def sigmoid x return 1 for 1 plus np explorer min x, and def predict x weeks and bias. So I will predict class to return y predict to return y predict. This code defines two functions and a prediction function using logistic regression. The first function is sigmoid. Sigmoid is mathematical function that calculates the sigmoid activation for a given input x. The sigmoid function is commonly used in logistic regression to map any real value number to a value between 0 and 1. The function is defined as 1 per 1 plus x for min x, where explorer is exponential function. So the second function is predict, is x and weeks and bias. So it requires the input x, which is represent the input data, from week, which represent the week of values for the logistic regression model, and bias is which represent the bias term. So this function calculates the predicts class using logistic regression. So how to implementing an expression of code for modeling? So I create a code for number first time. I create import numpy as nv, and then class. I build class logistic regression like dev init, dev feed, and dev predict, and dev sigmoid. From import numpy as nv, the code starts by importing the numpy library, which is used format operation, and then class logistic regression. So the holistic regression class is defined with two main method feed and predict along with an additional helper method sigmoid. The init method is class constructor, which is initials the learning rate and the number of iteration and iteration. It also initials the weights and bias to none. And then I create the feed self xy. So the feed method is used to train a holistic regression model. It takes two input, x input future and y is target label. So this method initials the weights and bias to 0. Then it performs gradient descent by iterating for an iteration. And then I create the predict self x. It means the predict method takes the info future x and returns the predict class label. And then dev sigmoid self z. The sigmoid method is helper function that calculates the sigmoid activation for a given input z. So this method applies the sigmoid function 1 per 1 plus np x exponential means z. So elements wise the input z. So from the Agile project, we will summarize the conclusion from this project. I have to 5 important from building scratch logistic regression. And the first is implemented. The implemented logistic regression algorithm follows a gradient descent optimization approach to estimate the model parameters. And second part, after training. So after training, the algorithm can make a prediction on new data by applying the learn parameter to the logistic function. And third part, conclusion, the code implementation. So the logistic regression code from scratch provides a solid foundation for understanding and implementing the algorithm. And next conclusion is algorithm logic into a class. So this means the code encourages code reuse and maintainability, make it easier to integrate into large machine learning projects. And finally, clean structure and modularity. It allows for easy customization and experimentation while its versatility and algorithm interpretation cover capabilities make it a powerful tool in machine learning. So thank you for joining my previous project. You can look my code project is via GitHub, and also I create my project, this video, in Medium article. You can read from right from me. Thank you.